Gateways. In this part of the course, we are going to learn a little more about gateways. We will see some examples of how and when to use them. Gateways are elements used to control divergence and convergence of the flow. That is, they act as points of decision or of synchronization. We have previously said that their behavior depends upon where they are located within the flow. If there are many routes out of the gateway, then it is being used as a divergence point. And if there are many sequential flows arriving at the gateway and only one exiting, the gateway is being used as an element of synchronization. We have also mentioned that there are many types of gateway and that their behavior is represented by an icon within the diamond. The first type of gateway that we are going to see is the parallel gateway. This gateway, as an element of divergence, enables you to generate many concurrent or parallel routes. Therefore, it is a point in the flow where there are many outgoing flows that can be executed simultaneously or in whatever order. BPMN states that it is not necessary to use it and that it is possible to generate routes in parallel from an activity. However, it is recommended to use it for clarity, so its use is considered good practice. The parallel gateway, used as an element of convergence, allows you to join many routes that are executed in parallel into just one. In the process, we can observe that the activities of invoice and take product from inventory can be performed in parallel or in whatever order, for which we use the parallel gateway as an element of divergence. Additionally, we can establish that the delivery to client activity can only be performed after the invoice and take product from inventory activities have been completed. It is for this reason that we use the parallel gateway as an element of convergence. In this case, the flow waits at this point until all the incoming flows arrive at the gateway in order to continue with the next activity. Then we have the exclusive gateway. The exclusive gateway, as an element of divergence or of decision, represents a Y-junction in the route. That is, a point in the process where only one of the many routes available is chosen. There are two types of exclusive gateway, one based on process data and the other based on events. The exclusive gateway based on process data is represented by a diamond without an icon inside, or with an X. The exclusive gateway based on process data indicates that the decision will be taken after evaluating a business condition. It should be taken into account that this business condition should be completed in a step before arriving at the gateway. For example, if the amount of the loan requested exceeds X value, then the request should be passed to the evaluation committee. Once the process arrives at the gateway, the amount of the loan should be known because the gateway will only evaluate the business condition. In this process, we can see an exclusive gateway that takes a route depending on an action taken previously. This action can be to request more information about the suggestion, or to respond to it and execute the relevant actions. The exclusive gateway, as an element of convergence, enables joining alternative routes into only one. It is only used when it is necessary to synchronize the flow later on. We are going to see an example to make it clearer. In this process, we need to represent the following business situation. It is necessary that the deliver to client activity is performed once the two routes that are executed in parallel are finished, i.e., when the product and the invoice are ready for delivery. If we use a parallel gateway, as we can see in the diagram, we will have a diagramming error. As we can see, there are three routes arriving at the parallel gateway, but actually only two will be executed. There are two flows exiting from an exclusive decision. So the process will remain in the parallel gateway, waiting for a flow that will not arrive. It will be stuck at this point. To represent this business situation correctly, we should synchronize the exclusive routes into only one before arriving at the parallel gateway. Otherwise, the parallel gateway will continue to wait for 3 routes, and as we have seen, only 2 will arrive. Thus, it will never pass to the following instance of the process. The correct way to diagram this business situation would be as shown in the diagram, using an exclusive gateway as an element of synchronization of alternative flows that indicates if the product exists in the inventory or not, and make it that only 2 routes arrive at the parallel gateway. We can therefore conclude that the exclusive gateway, used as an element of convergence, is only used when it is necessary to convert many alternative routes into only one in order to perform another type of synchronization. Yet in other cases, it is not necessary to use the gateway, given that it is equivalent to making the alternative routes arrive at the activity, whereas in reality, only one of them is going to arrive. The other type of exclusive gateway is the event-based exclusive gateway. This gateway represents a point in the process where only one of many branches of the process can be selected. The difference between this and the exclusive gateway based on process data is precisely that the decision is not taken in an explicit way, i.e., it is not based on process data, but on events. This figure offers many alternatives, and once a branch of the process is activated, the other branches remain unavailable. For example, let's suppose that within a process, the response from the client is awaited, where we have a group of activities if the response is yes, and another group of activities if the response is no. For this reason, the route taken depends on which of the messages is received. For this case, we should take into account that the yes message and the no message are different messages with different values and properties. In this other business case, we have 2 possible events: that the client delivers the documents within the established time, or that he doesn't. To diagram the 2 possibilities, we will therefore use an event-based exclusive gateway, so that the event which occurs first will immediately disqualify the other alternative. Another type of gateway is the inclusive gateway. This gateway, used as an element of decision, indicates that one or more routes can be activated from many available. That is, it is a multiple choice or flow point where many alternatives are offered and one or many routes can be taken. This decision is based on process data, which signifies that once the flow of the process arrives at the gateway, the values should be known in order to evaluate each business condition. In the example, we can see that, depending on each client, one or more routes will be made available. It is possible that the client wishes the travel agent to be in charge of everything, tickets, hotel, transport, tours and insurance, whereas other clients only want tickets or travel plan or insurance. Or tickets and travel plan without insurance, etc. As you can observe, the inclusive gateway used as an element of decision allows us to represent these multiple choices. BPMN states that you can use conditional sequence flows to diagram the behavior of an inclusive gateway. We can see that it is equivalent to use an inclusive gateway or conditional sequence flows exiting the activity. The only restriction is that the conditional sequence flows can only exit from an activity, i.e., they cannot exit from an event nor from another gateway. The inclusive gateway as an element of convergence indicates that many outgoing routes of an inclusive gateway, used as an element of divergence, can be synchronized into just one. For the same process of prepare trip, once each of the activities has been finalized, the travel agent should deliver the travel package to the client. But as we know, each case or each trip is different. For this reason, sometimes we may have many routes available in parallel. There can be 3 routes, or 2, or just 1. The way to synchronize this is by using an inclusive gateway as an element of convergence. And by this means, we can guarantee that delivery to the client can only be realized once all the parallel activities have been completed. The complex gateway, as an element of divergence, allows you to control complex decision points that are not easy to manage with other types of gateways. The complex gateway as an element of convergence allows you to continue to the next point in the process when one of the incoming sequential flows fulfills a given condition. It is possible to determine which of the incoming sequential flows will continue the process flow. For example, it can be determined that 3 out of 5 incoming sequential flows are needed.